Now you might say, Dr. Hossain, you taught us different distance and similarity measures before. We wrote our own functions. Is there any way I could use those functions to find k nearest neighbors? I'm happy that you asked this question. Of course, you can use your own distance functions. If you provide a function name within quotations, you are referring to a function that Scikit-Learn has. You can directly write a function name here, the name of a distance or dissimilarity function that you wrote. For example, let me copy some of the distance and similarity functions that we wrote before. I am borrowing the functions for cosine similarity, Jaccard similarity, Euclidean distance, and Manhattan distance. This is Manhattan. Scikit-Learn has a Manhattan too. To assure that there is no confusion, no conflict between our functions and other functions in Python, let me rename these functions by adding a word my as a prefix of these function names. That is, I change the function names to my Manhattan, my Euclid, my Jaccard, and my cosine. For sure, there are no such functions in Python or in Scikit-Learn with these four names. Now, if I write without any quotation that metric is equal to my Manhattan, then the function that I named as my Manhattan will be used for the nearest neighbor computation. Similarly, you could put my Euclid here, and the function that we wrote to compute Euclidean distance will be used. This result is exactly the same as if you do not write anything as the metric parameter. That is, when you do not mention any metric, by default Scikit-Learn will use its own Euclidean distance function for finding the nearest neighbors. You can come up with your own distance or dissimilarity measure and tell nearest neighbors algorithm to use it simply by writing the name of the function here as the metric parameter. For this practice, I'm changing k to 6 just to see more nearest neighbors and to do a little bit of testing. Now let me ask you another critical question. Can we use Jaccard in place of metric? I will pause for a bit. No, I'm kidding. You can pause the video if you want to think if Jaccard is appropriate in place of metric for this nearest neighbor computation. The answer is no. We cannot use Jaccard because Jaccard is a similarity measure. This nearest neighbor function does not know that the function you wrote is a function for computing similarity. It expects that you are providing a distance or a dissimilarity function. Since Jaccard similarity varies between 0 and 1, 0 being no similarity between two vectors and 1 being exact match, we can easily write 1 minus my Jaccard to compute dissimilarity. However, we cannot directly put computation in place of an expected function parameter. So we need a different function that will do the 1 minus my Jaccard thing. Let us call that function Jaccard diss for dissimilarity. Then we can provide this Jaccard dissimilarity function here as the metric parameter. You run using brute force approach and the nearest neighbors are generated based on Jaccard dissimilarity. These distances of the nearest neighbors are Jaccard dissimilarities now. Note that the row index sequences of the nearest neighbors we got using Euclidean distance and the row index sequences we got using Jaccard dissimilarity are slightly different. That is, different dissimilarity and distance measures may give you different nearest neighbors. Now, let us say that we do not want to write a different function for Jaccard dissimilarity. When we do not want to write a function but desperately need a function, what do? We use Python's lambda function. We can create the lambda function directly on the fly with two vector parameters a and b because my Jaccard needs two vector parameters, and then calculate 1 minus myJaccard with parameters a and b. That's it. Running this, you have the same result when you used the Jaccard dissimilarity function, obviously. Same goes with myCosine. In place of myJaccard, if you put myCosine, the lambda function will represent cosine dissimilarity. In a nutshell, you can use your own distance or dissimilarity function, or you can say nothing about distance. If you say nothing about distance, the nearest neighbor's object will use Euclidean distance. Should you use dissimilarity measure with KD tree and ball tree options for algorithms? I wouldn't, because those algorithms work well with true distance measures. A dissimilarity might not be a true metric distance. Therefore, I would use the brute force algorithm if I use dissimilarity measure that is calculated from a similarity measure. Nearest neighbor computation is one of the most fundamental algorithms in machine learning. From ranking to searching to classifying, in many applications, k-nearest neighbors play a vital role. See you soon.